All right, ladies and gentlemen, today is Growing, Investigation 1. The goal for today's investigation is that we're going to be identifying and working with exponential growth in graphs, equations, and tables. We have 4 units to work from in this particular investigation, so take a few days to complete them. They go very quickly. Getting 2 done a day is not out of the question. Okay, so just go ahead and work at your own pace. Try to race through this. It's not too hard once you get the big idea. Now, about that big idea, here's how it works. Okay, the thing you're going to want to get down in your notes first is the difference between standard form and exponential form. Now, standard form here is a set of repeated multiplication. So I've got 2 times 2 times 2 times 2 times 2. All right, I'm multiplying 2 times itself 5 times. Now, when we come across things like this, it just doesn't make sense to write that all out. We save paper by writing it in exponential form. An exponential form is something where we take a number, a base number, and we indicate with the exponent, okay, how many times we are multiplying it by itself, okay? Now this gets a little trickier when we talk about exponential growth, okay? Now, exponential growth works like this. Exponential growth is when we have a relationship, okay, like a linear relationship, only instead of a linear relationship that goes up plus 2, plus 3, plus 4, it goes up plus 2, plus 2, plus 2, plus 2. An exponential equation goes up by times 2, okay? So to get from... So for here I've got an example where I go up from 2 to 4. Okay? I don't add 2 to get that. I times 2 to get that. I went times 2. And then get to 4 to 8, I had to times 2 as well. And to get to 8 to 16, I had to times by 2 as well. And if I'm looking at adding this, it just gets larger and larger and larger. And when it's graphed, it forms this really fantastic shape called a parabola, where it shoots up in this direction here, faster and faster and faster and faster, until it's almost going vertical. Never quite vertical, but almost vertical. And it's expressed in the equation as the exponent having a variable inside it. So this is 2 to the x power plus 1. Okay? So as an equation, we're going to have the exponent located inside, the variable actually located inside an exponent. Now, how does that show up? Well, we'll cover that in a bit, but first let's talk about where we actually see this exponential growth. Okay, exponential relationships exist all over the place in the real world. In fact, they're one of the most common things in the real world. And exponential relationships, we find them in things like cell reproduction. Okay, when we start out with 1 bacteria, we end up getting 2 bacteria. It splits into 2 pieces. And then those 2 pieces split up into 4 pieces. And those 4 pieces split up into 8 pieces. And so on and so on and so on. They just get bigger and bigger and bigger and bigger. We also notice this in population growth. If every person has 2 kids, how long before we get a certain population? We also see it the other way. If we have an animal that's going extinct, if each year we're losing a certain percent, how many years before it goes away? We also notice this a lot in computer chips. And here we've got some examples where back in like the 1970s, this was a 5 megabyte hard drive. It held about as much as 1 photograph. And that 1 photograph in a few years turned into this SD card that had 128 gigabytes. Okay, it held thousands of these old hard drives. And then about 9 years later, we get something exactly the same size that holds 128 gigabytes. Okay, it's gotten 100 times larger. And that works because they are able to actually physically cut the component elements of those chips into smaller and smaller parts. Okay, every year they basically every couple of years they figure out a new way to cut them in half and get twice as much power out of the same size chip. We also notice this in money with interest. How much are you going to lose money? How much are you going to increase your money by over a series of years? Okay? And you'll see your money double after so many years is really, really important. Knowing the economy, making the big bucks in the stock market, you need to know exponential relationships, okay, and growth rates. Now here's an example of an exponential equation from actually a real-life example. Many, many years ago when I was in middle school, Eddie York was in my middle school class, and Eddie lent me $1, and I agreed to pay him back $2 the next day, $4 the day after that, and so on until I paid him back. And every day I promised that it would double. I made a little mistake here. This should actually be an 8. Okay, so at day 0, I owed him $1. Okay, if I had paid him back that same day, I wouldn't be in trouble today. But one day went by and suddenly I owed him 2. Then I owed him 4. Then I owed him 8. Okay, the way this works first is to make this into a actual equation, we start with y. Okay, and y here is my days. Now, something to remember is that any number to the 0th power equals 1. All right? That's something that you have to remember. So if I had 50 to the 0th power, it would equal 1. If I have 30 to the 0th power, it also equals 1. Okay? Everything to the 0th power equals 1. We'll talk more about why that works at a different time. But what I want to look at is what am I multiplying everything by? To get from 1 to 2, what did I have to multiply by? I had to multiply by 2. And then to get from 2 to 4, I had to multiply by 2. And then to get from 4 to 8, I had to multiply by 2. And my question becomes, well, I know I'm increasing by 2. I know 2 is my coefficient. However, how many times am I doing that? Well, I'm going to experiment a little bit and say 2 to the x power. All right? So after 3 days, I should have y equals, all right, if we got to the 3 days here, I should have y equals 2 to the 3rd power, and 2 times 2 times 2 equals 8. So this is my equation. All right? Notice how the variable, the real math, exists in the exponent. Okay? Keep an eye on that as you work through these problems. All right, ladies and gentlemen, have fun. Ask questions of your neighbors. Ask questions of me. Feel free to look around on the internet for your answers as well, and share what you've learned. Have fun.